our presentation. We have been taking drinking water samples or tap water from 3 different locations: Moholt, Midtbyen and Byåsen. We chose those locations because we had access to them and because they were a bit far apart, so we wanted to see if the distance would give some differences in the results. Both Byåsen and the Moholt sample was taken Monday morning before the lab, but the Midtbyen sample was taken on Saturday and stored in the fridge for a couple of days. We have tested turbidity, conductivity, color, and pH. pH in drinking water can have an impact on the taste, with a low pH that can give more sour water, and high pH can give more bitter water. And then it has an effect on the corrosion. With a low pH, the water is more corrosive, and the high pH then is less corrosive. And for the efficiency of the disinfection, a low pH will give a more effective disinfection, and a high pH does the opposite. And because of this, the Norwegian regulations wants the pH to be between 6.5 and 9.5. And this is our results from the pH. And we found that the pH at Moholt was the highest, and the pH at Byåsen was the lowest. And we think this could be because of the residence time in the pipes, that because it takes a longer time for the drinking water to get to Byåsen, more reactions can happen that can lower the pH. Yes, then the turbidity is the measurement of the water's cloudiness caused by systemic particles. The particles that can contribute to the turbidity is organic matter, microorganisms, and clay, for example. We have measured the turbidity using a turbidimeter that measures the light intensity that passes through the water sample, and then the particles in the water will scatter the light beam and reduce the intensity. The turbidity is usually not harmful for drinking water, but can indicate that the water is polluted. We therefore aim for a low value to make sure that the water is clear, and to prevent also sedimentation. And sedimentation in the pipes can also lead to corrosion and bad taste. The limit is 1 FNU from the treatment plant and 4 FNU at the consumer. Then this is our results, and we see that the lowest value is at Moholt. We also believe that this is due to the distance from Jonsvatnet, because the requirement was lower there and at the consumer. We also see that the highest value is measured at Midtbyen, which is also the place with the oldest pipes. So we believe that this may be the reasons also.
So what's conductivity? Conductivity is the water's ability to conduct electricity in a solution. This is due to the nature of the components in water. It's gonna be charged molecules. It's gonna depend on the charge of the molecules and also the concentration. Higher concentrations means higher conductivity. Conductivity can be measured with a conductimeter. It normally consists of 2 electrodes that goes into the sample and will measure the electricity in that sample. Some samples have higher and lower, but they all been measured at 25 degrees, because temperature also affects the conductivity, because temperature accelerates the movement of particles in the water. That means that they can create higher charges. The conductivity is going to determine how many minerals are in the water. So the water should have like a proper value in order to indicate that there are enough minerals and make it healthier for the consumer. We did two measurements per sample. The first measurement we didn't shake the sample, and the second measurement we shook the sample to see what will happen. Ideally, the conductivity should be higher when we shake the sample, because that means that the particles in the water are moving around faster. Mohold presented the second highest value after Midbien. We think it's also because Midbien should use old pipelines. This is part of the city center, the oldest part of the city center. And when pipelines are made out of metal, then there is iron corrosion between the water and the iron, which will increase the conductivity. The units for these are microsiemens per centimeter. Microsiemens is the conductance of a substance, here per centimeter. That's what it basically means. Then we also measured the color. Color is used for quality, safety, but also to measure the risk of water. It can impose some health risks to consumers. Color is mainly due to impurities, organic matter, but also minerals. It's measured by it can be measured easily by visual comparison, just by looking at the samples, but in a more sophisticated way with a colorimeter, like we did. As you can see here in the picture, color does not only depend on the concentration, but also on the nature of the minerals, because some minerals have more intense colors. That means that the color is going to be the units, the result of the colorimeter are going to be higher for those samples that have more intense colors in the minerals. And yeah, of course, it also depends on the concentration. Here, the standard unit is milligram per liter of platinum. Platinum has been used as a standard for the comparison. What we did is for each sample, we measure the sample filter and unfiltered to see how these organic molecules play a role in the color, but also to see how shaking plays a role as well. Because once the sample was filtered, we let it stable on the table for some time in order to sediment. And this leads us to the conclusion. In conclusion, in our semester project in water chemistry, we found some valuable insights in water sources from different locations in Trondheim. So you can see the water treatment plant is somewhere here, and we did the measurements in Mohold, Midbien, and Byåsen. The distance between the water treatment plant and Byåsen and Midbien is very similar. Mohold being closer to the water treatment plant. This also can be reflected in the values that we got. Mohold having the highest pH, because there's no nothing that impedes a direct flow from the water station to Mohold. We also found that somewhere here there is a Steinan, which is water storage, where they storage the water before sending it to Byåsen. So the water stops here and then goes to Byåsen. That there is no direct flow. And Mohold and Midbien, they got directly the water from the water treatment plant. So also these values, since the source of water is the same, you will probably wonder why are the values slightly different. Also because there are very big geographical and demographical differences. Byåsen is a residential area with very low density of people there. Mohold has the highest density of people because there's this student city with a lot of complexes, towers and blocks. And secondly is Midbien, where there are more houses or attached apartments. And also the year they were really very different. Like Midbian is by far the oldest, and Mohol is quite recent. We can see that reflected on the values. The pH in Mohol is higher. We assume we hypothesized this is because there are a lot of limestones in the pipelines in Mohol, because students consume more water normally, and there is higher density of students in Mohol. That means that the water is being pumped out more often compared to the other places. Also, Mohol is close to the city center, where there's more like industrial activities or activities people are doing around that could influence water. And for the turbidity, Mohol has the lowest value, and we think the values are similar in Biosen and Midbian because of the distance between those places and the water treatment plant. Since the water needs to travel for longer, it has more time to interact and take some particles from the pipelines, in contact with the pipelines. And for the conductivity, we can see that Midbian has the highest conductivity. We think it's because of the old infrastructure, where pipelines are probably more metallic. There are more metallic pipelines there. And for the color, there is a huge difference. Mohol and Midbian having the highest color. We think it's because of the Steinen reserve here that stores the water for some time before sending it to Biosen. That means that the water can sediment, so that there is less pressure. So when there is less pressure in the water, that means that normally conductivity and color values should be lower. So these are the insights. It's worth mentioning that all the values are in a safe range that authorities think are safe. But yeah, these differences are mainly because of the demographical factors. Thank you for your attention.
Thank you. Thank you.